So why do we need operators? We need operators for the sake of doing some operations, right? So in our programming, so there are certain scenarios where we should be doing some actions. So in terms of doing those actions, we sometimes need operators. We take the help of operators and we try to do some functionalities. So for which we need to understand, first of all, what are operators, right? So when we talk about the operators, what is operator actually? It is basically a symbol. It is basically a symbol which is used for the purpose of what? Doing an operation. So based on the values they take and they do the operation, we generally divided them into what? Three categories. I'm just trying to quickly revise what we have discussed in the previous lectures. Okay. So once that is done, we'll move on to today's topic. Now, as I said, we take based on the number of values that we pass to the operator. It's nothing but the symbol. So we generally categorize them into three. What are they? Unary, binary, and ternary. If an operator is taking only one value, so value can also be called as what? It can also be called as operand, right? You can also call the value as operand. So if a operator is taking only one operand or one value to perform the operation, we call it as what? Unary operator. And if an operator is taking two values, basically two operands, and if it is trying to perform the operation, we call it as binary. And if it is taking three, we call it as ternary, right? So once it is done, we have understood the basically what we did next. There are a lot of symbols, right? There are a lot of symbols. We generally categorize them based on the type of operation that we are performing. So let's say I want to perform an arithmetic operation. So under arithmetic operation, how many operators we have? We have generally 5 operators. Give me a minute, guys. What happened? Sorry. So under arithmetic operators, we have generally how many? We have basically 5 operators. So what are they? Plus, which is used for the sake of addition, and we have minus, which is used for the sake of subtraction. And what else we have? We have multiplication, and we have two for dividing. We have two symbols. Okay, one is divider, which is for after dividing we need a quotient, means we need to use divider. And we have another symbol is for is nothing but we call it as modulus. And this is used for the sake of if you are trying to do a division and if you want remainder, then we go for using the modulus, right? So after arithmetic, what we have covered? Arithmetic operators, what we have covered? You guys remember? After arithmetic operators, what we have covered? So we have next what? Assignment operator. So if people remember what is an assignment operator, right? So if you have an value on the right side, an expression or something, and once that is evaluated or the value has to be stored on the left side variable. So then we go for what? Assignment operators, right? And under assignment operators, we have one symbol, which is nothing but equal to, through which we will be able to do what? We will be able to do the assignment, right? So next, completing assignment operators, what we have discussed? Comparison and relational operators, right? So we have discussed about comparison or relational operators. Both are the same. So what are relational operators? Why do we use relational operators? And how many relational operators do we have? You guys remember? So basically, relational operators are used for the purpose of checking the relation between values, two operands. Like let's say I have two operands, two values. I want to check which is greater, or I want to check which is less than. Right? I want to check whether they are equal, less than or equal to, or I want to check whether they are greater than or equal to. And I want to check whether they are equal to or not, or they are not equal to. Right? So basically, we have totally 6 operators under what? Under relational operators. Basically, we use them for what? For checking the relation between two values. Okay. So generally, where do we use them? We use them for writing conditions. Okay. So now in our programming, we write what? We write so many statements. Nothing but we write code. And out of the code, basically, the code will get executed in which order? From top to bottom, line by line, it will get executed, right? Now, all the lines in the programming, I don't want to get executed. I don't want all the lines to be executed. Few of the lines, I want them to get executed based on some condition. Okay. I want them to execute on certain purpose. So there is a purpose. If that purpose is met, then I want those code to be executed. Okay, I want those lines to be executed. So for doing such operations, we use what? We use relational operators. Okay, so we use those operators and we write conditions. We write conditions, and if the condition is based on true and false, we generally do what? We are going to decide whether the code has to be executed or not. Now, after that, the next topic, there's nothing but today's topic, we need to discuss about logical operators. Okay, so the next topic is logical operators. Now, let's focus on this topic now. So, what are logical operators? As I told you, so now basically we use relational operators, right? Like let's say I have 10, whether this is greater than this or not. Based on that, I want some lines to be executed. Okay, so some code to be executed. Based on this, I want this code to be executed using this condition, right? Now, if I have only one condition, and if I want to write that condition, it is okay. Okay, it is okay not to take any help of any other operators. But I have multiple conditions here. Okay, what is that? I have multiple conditions. Like example, I have condition one. So condition one, I have condition two. Like that, I have so many conditions. Like let's say I have some other condition. If 50 equal to 50. Okay, so like this, I have so many conditions. So multiple conditions I have. So based on multiple conditions, I want a logic to be executed, a code to be executed. Then how to write that? In generally, you cannot write like this. Okay, if you have multiple conditions, you cannot write like this. Okay, so for which, what we need to do? We need to combine them now. What I need to do? I need to combine these conditions. Without combining, we will be not able to separate them. So because they are different conditions here. If they are separate conditions, there should be a way we need to combine them, and the two has to be executed, and based on that, the decision has to be taken by the JVM to whether to execute that code or not. Now, how to combine them? How to combine the multiple conditions? That's where we use the logical operators. Okay. So when to use logical operators and what are logical operators? Logical operators are used for the purpose of combining conditions. So if you have multiple conditions and if you want them to be combined, okay, then we go for using logical operators. And talking about logical operators should be applied on what? Only Boolean types. Now, you know, right? So when you are using uh, when you're using relational operators, so all relational operators evaluates to what? What they will give you as a result. So they have to give you a Boolean value. Am I right? So after once it is getting evaluated, it gives you what? It returns you a Boolean value, a true or a false. Now, if it is giving a true and false, so basically we can say them as Boolean, right? Boolean operators. So that's what we Boolean types. So that's what this is. So logical operators always needs to be applied on what? They need to be applied on Boolean types. So as we are trying to combine conditions, conditions will always evaluate to Boolean types. So that's where we'll be able to use these logical operators, right? So now, how many logical operators do we have? We have totally 6 logical operators. What are they? We have logical not, for which we use the symbol this. Okay. So we use the symbol not, exclamatory, right? So we have the symbol where if you see your one, in the keyboard, you will see one, right? So that's where you'll have the symbol. So we need to use this symbol. So we call it as what? We call this as logical not operator. And we have another operator, which are 2 and symbols. Okay. So this is, we call this as what? Short circuit end. We call it as what? Short circuit end. And third one, we have only one end. Okay. So there are 2 ends and there is one end. So we call it as what? Logical end. Okay. And we have short circuit or for which we use this symbol, 2 pipe symbols. Okay. And have one pipe symbol, which we call it as logical OR. And the last one we have is logical XOR, which can also be called as exclusive OR. Right. So these are the different symbols or different operators we have under logical operators. We use these symbols for the sake of combining the conditions. Okay. So we write conditions using relational operators. And if we have multiple relational operators, if you are trying to form multiple conditions, at that time, we use these symbols to combine them. Okay. Now let's see some examples around these symbols. Okay. Let's take each operator and let's try to see some examples like how to use them and how they will work. Okay. So in which, firstly, let me take logical NOT. Okay. Let's take logical NOT. So now, talking about logical NOT, this operator takes how many values in order to evaluate? So we told, right, we have discussed, right? Every symbol, they are classified into three categories, unary, binary, and ternary. So based on the number of values they take and they perform the operation, we call them as what? We will be calling them as unary, binary, ternary. Now, logical NOT falls under which type of operator is nothing but it falls under unary operator. Means it will take only one value, okay, and it will perform the operation. So, just a minute. Just a minute, guys. Okay. So what is this? Logical NOT, and we call it as what? A unary operator, because it takes a single condition, means I mean to say, it will take only a single value. Okay. And now a single value, it tries to perform the operation. It doesn't require multiple operands. It requires only, so what? Only single operand to perform. So when do we need to use this? When do we need to use this? It's nothing but we will use this to complement the given condition or expression. Okay. If this operator is used for what? For complementing. Now, if a condition is giving you a value, and if you wanted to negate that, means you want to reverse that. Okay, so a condition is giving you a true and you wanted to negate that, means you wanted to change it, you wanted to reverse it. Like if it is giving you true, you wanted to make it as false. Okay, so to negate the values of the results of the conditions, we go for using what? We go for using logical operator. Okay, so logical NOT operator. So what is this? This operator, what it does? This operator will complement. Okay, this operator will complement the given condition. Okay, given condition, or we can also say it as given condition or expression. Okay, so what is the syntax? Let me write the syntax. So you don't worry about what is this if here. So we use this particular statement for writing conditions. Okay, so in the next lectures, in the future classes, we will cover about this if come in and out. So now don't worry about this. But for now, to make you understand what is this, we use this for the purpose of writing conditions in our programming. So I have a if. Okay, so inside the if, I'm trying to write a condition. Okay, or otherwise, let me not mention this if here. Let me say I have multiple conditions here. Okay, so multiple conditions, let me write them. So I have a condition or combination of conditions. I have combination of conditions. Okay, so once this is executed, it will return me what? It will return a Boolean value. Okay, this will return a Boolean value. Now, let's say now in this, the condition returns me true. I wanted to negate that. I wanted to reverse it. So means if it is giving you true, I wanted to make it as false. So what should I do? Just in front of this, put this negate operator. Okay. So this logical NOT operator, just put it in front of this condition. So now what happens once this old condition gets executed,
it will reverse the value of what the result that is coming out of this condition or a combination of condition. Understood? So this is the syntax of writing the logical NOT. Okay, so this is what basically we do it. Now, if you have to look at the truth table, like let's say, let me put a condition here. Let's say I have 10 greater than 20. Okay, and I didn't spoke about this, but still I'm using it. Okay, and let's say I have 20 not equal to 30. Let's say I have this combination. See, these are combination of conditions, right? This is one condition and this is one condition. I tried combining them using an operator. Okay, so which operator I have used? I have used double AND operator. Okay, so I have used this operator. Now this will return me some value. Okay, I wanted to reverse it. Just put this condition here so that the result will be negated, which means that the result will be reversed. If it is giving you true, it will be turned into false. Okay, so now basically we generally talk about truth tables here. So this truth table will tell you how the values will change. Okay, so let's say if the condition is true, then the condition will be inversed. So what will be the inverse condition value that will come? If it is true, it will convert that to false. If it is false, it will convert that to true. Understood? So this is the truth table, looking at which we will be able to understand how the things works for logical NOT. Okay, now what is the other symbol we have? We have short circuit end. We have what? The second symbol we have short circuit end. For which what we use? We use double AND operator. So are you able to understand logical NOT, right? Is it clear? Understand that it is used for the purpose of inversing the condition value. It will inverse whatever the condition that returns you, it will just inverse it. Okay, so that is what basically it will do. So anyhow, we will be using them. If it is still not clear, just try to remember what it is doing. So when we are trying to work on that in the future classes, you will be able to understand that. Okay, now next, what is that we have? We have logical AND. So logical AND. Hello, any questions? Any questions, guys? No, right? Okay, so let me condition. Let me continue. So we have logical, short circuit AND operator. So it is nothing but it uses double AND symbols. Okay, so the syntax, how do we use this is nothing but I have condition 1. Okay, I have condition 2. I have condition 3. Okay, so if I have a combination like this, okay, and if I want the combination to be combined using double AND operator, we generally write the syntax in this way. Okay, so what is the truth table? So how basically it will work? Let's look into the truth table. So by looking at the truth table, we'll be able to understand this. Okay, so let me say this is my condition 1 and this is my condition 2, and by combining these two, okay, if condition value is this and conditional 2 value is this, then what is the condition 2 result? Okay, so let's say if my condition 1 is true, okay, my condition 2 is false. So what is the result that I will get? I'll get the result as false. For logical AND, if one condition is true, and see, this condition is true and this condition is false. Okay, so in this case, what will be my result? And you can put also this. Okay, so I don't want to make it complicated. That's the reason I'm just taking only one. So what is it? I have my first condition which is giving me true, and my second condition which is giving me false. Now combining these two, what is the result that I will get? False. Now I have my condition 1 false, and I have my condition 2 giving me true. So in this case, what is the result that I will get? Again, false only. Okay, now I have the third one. I have condition true. First condition is true, and my second condition is also true. Now in this case, what is the result I will get? I will get result as combination of the result as true. Okay, and again, I have my first condition as false, and my second condition is also evaluating to false. In this case, what will be the combination result? It will give me false. So, logical AND operator returns you true when both the condition evaluates to true. Okay, if both the conditions evaluates to true, then only it will give you the result as true. In all the remaining cases, it will return you false. Got it? Which means that when my condition gets executes, my condition will execute when the condition is true. If my condition is true, then the piece of the code which I want to get executed by the program will get executed. My condition is false means then it will not enter into that particular block and will not execute that code. Okay, so if you are using AND operator and if you are combining the conditions at that time, when that condition will make sure that it gets executed, when both the conditions or multiple conditions are resulting to true, all the conditions are resulting to true, then only it is true. If one of them is false or only one is true, then in that case, it will always return you what? It will return you false. Okay, so remember here, remember this truth table here. Okay, so let's see some example. Let's see an example for this. So let's say I have an integer, a variable, which is a, and it's storing a value 10 here, which is initialized with the value 10. And I'm taking one more variable, which is b, and this is carrying, it is storing a value 2 here. So now if I try to print this, okay, if I try to print this, like how, let me write the condition here. How to write the condition here? I'm saying my a is greater than b. Okay, if a is less than b, and okay, and what is that I'm checking? So I'm using, let me use this operation, plus plus of a. So you know, right, what happens with this? So we have seen also increment and decrement operators, right? How increment and decrement operators works. So based on this, I'm saying here plus plus a. So what happens here in using this operator? When I say plus plus a, what happens? If I'm using pre-increment operator, how it will work? Can anyone tell me how the pre-increment operator works?
A value 11.
Yeah, so it will evaluate first, which means that it will increase first and then it will be used in the application, right? So it will be first incremented and then it will be used. So as I'm using pre-increment operator, it is going to first increment the value. Okay, and what I'm doing here, I'm checking it is greater than plus plus of b. Okay, so now can anyone tell me? So here a is what? 10. So b is what? 2. B is what? B is 2. So now 10 is less than 2. Is it false or is it true?
False.
So this gives me false. And coming to the next one. So plus plus of a. What happened here? A became 11, right? And I'm saying plus plus of b. What happens to 2 here? B is holding a value 2. So it becomes 3. I'm saying 11 is greater than 3. So the condition evaluates to what? Is 11 is greater than 3 or it is not greater than 3? 11 is greater than 3, right? So which means that it is giving me false and this is giving me true. So what will be the final result? Can you look at the truth table and can you tell me? So my first condition is giving me false and my second is giving me true. So what is it I will get result? So what is the output I will get? Can anyone tell me?
False.
Yeah. So let's execute and see afterwards. So now let me write one more condition. Okay, so let's execute this and let's see. Let me code this in the program and let's see whether it is giving me false or not. So let me go to my notepad. Okay, I'm using my editor. So let me create a new file and let me write a class. So what is that? How to write a class? I need to use the keyword class and I need to write the class name. So what is the class name I wanted to write here? So let's say, what are these? Logical operators. Logical operators example. Okay, I'm naming this class as logical operators example. Now, to execute this program, JVM always looks for what? Main method. So how to write the main method? Public static void main and pass the string array argument to it, parameter to it. Okay, so it takes the string array arguments. Okay, string array parameter. So now what I need to do here, let me write the code what I have written. So what is it? I'm trying to take a. So what is the value I'm giving? What is the value I'm initializing to here? 10. So let me take one more variable, which is b, and I'm trying to initialize this with a value 2. Now what I wanted to do, I wanted to print certain conditions. I will write some conditions and I wanted to print them. I'm using what? I'm using the system.out.println statement. So what is it? If A is less than B and plus plus of A is greater than plus plus of B. So what is that we have expected? This will return us false. So let's check whether it is giving us false or not. Okay, so this should return me the value as false. Let's check whether it is giving me that or not. So for which what I need to do first? I need to save this. Use Control S. It will get saved. So I'm saving it with the name logical. I'm trying to save this file name as class name only. So my class name is logical operators, right? Example. Use the extension .java and just save it. So now go to your terminal, nothing but your command prompt, and let's move to that particular folder. So I have that particular program written in day 9. So let's go in, and now to come first I need to do what? I need to compile the program. Before executing it, I need to compile, for which I need to use a tool called as javac. The command I need to use is javac. Let me use javac followed by what? What is the class name you have given? Logical. Let me check whether it is saved or the. Okay. What happened here? Why it is not giving me? It is not there in Java 9. Day 9 only, right? One second. It is not. Just give a minute. Okay. It has taken a space. Let me remove the space. It has taken a space along with the name. So I just removed it. Now, what is that? I need to use the command called javac for compiling and just click on the tab. It will automatically it will complete that. So let me click on enter. So if everything is fine, it will execute and a dot class will get generated. So there is a dot class file that got generated. Now use the command Java for executing this class. So what is the class name? Logical operators example. Remove the extension and click on enter. So yes, the result is false. So is it clear, right? Now let's move on to the other operator. Now, after explaining this, I will tell you the difference between the short circuit operator and the operator which we are about to discuss now. Okay, so the next we have what? We have logical end operator. We have the next operator is what? Logical end. Logical end, which is nothing but we use only one end symbol. Okay, just a minute. So, okay, so the next operator we have logical end operator. So we'll talk about the difference between these two because both are going to do the same thing. But what is the difference between these two? We'll discuss. Now, why do we use this logical end operator? This is also used for the purpose of combining the conditions. Okay. So if I have multiple conditions and if they want to get executed, then I have to use this particular operator. Okay, so for combining that operators, we use this particular operator. Right. Now, how this will be used? So let's see the syntax. Syntax for is this. Okay, you will have condition 1 and you have condition 2. Okay, for combining them, we use this particular operator. We use this symbol and we try to combine them. Okay, now what is the truth table for this? How the truth table looks for this? Let's see this. Okay, so I have condition 1, I have condition 2, and I have combination of condition 1 and condition 2. So if my condition 1, first condition is true, and my second condition is false, the result will be false. So if my first condition is false and my second condition is true, the result is false again. If my first condition is true and my second condition is true, then the condition is true. Okay, my first condition is false and my second condition is also false. In this case, also it returns me the result as false. Okay, if you see both logical short circuit and a logical end. Two tables are same. They are going to work in the similar fashion. Now, what is the difference? What is the difference between logical end and this? So if both are going to have work in the similar manner, what is the difference is? So why it is called as short circuit operator is, okay. Now, when it is executing, see here, where do we write the code? So now let's say if it is executing this, so I have written two conditions here, okay. So now let's say 10 greater than 20 and I'm writing 30 less than 40. Okay. Now, if you see this condition, let me use this particular short circuit operator. So in this case, what happens? Now, when it encounter the first condition, this is first condition, right? So when it encounter this condition, if you see here, 10 is greater than 20, right? Which is nothing but false. When it encounters the first condition is giving you false, and at that time it will not go for checking this. It will stop there itself. It is having a brain of understanding that anyway the other condition after executing that condition, whatever the result it could be, whether it could be true or false, but still it is going to be false only, right? So why to check that? Why to evaluate that? So it will not go and it will not evaluate the other condition. Understood, right? So why it is called a short circuit end? The reason is if the first condition is giving you false, then it will not go to the second condition and it will not evaluate that, which means that it is able to improve the performance but avoiding executing that. Got it? So that is the advantage of what? That is the advantage of short circuit end. Whereas the other end operator, which we call it as logical end operator, even though the first condition gives you false, okay, it will still execute the second condition. Understood? So that is the difference between these two operators. Understood? So both are doing the same job, but what is the difference? One, if it identifies the first condition is false, at that time it will not go for the second condition. It will not go and check. It will not go and check the second condition. It will stop there only, and it improves the performance by not executing the other logic. It will be able to decide by the first condition itself. Okay, so that is about logical end and short circuit end. Now let's move on and let's see the fourth operator, which is what? Again, short circuit or short circuit or, which uses two pipe symbols. What are they? Which uses two symbols, two pipe symbols. Now, how to put it? What is the syntax? I have condition 1. Okay, I have condition 2. Now I want to combine them. So you just need to put this operator here. Okay, you just need to put this operator here. Now, what is the truth table for this? So what is the truth table for this? It's nothing but the truth table looks like this. So I have condition 1, I have condition 2. So if condition 1 and condition 2 are combined using this particular short circuit OR operator, if first condition is giving me true and second condition is giving me false, it will give me the result as true. Okay. If first condition is giving me false and second condition is giving me true, it is still going to give you result as true. If my first condition is true and my second condition is also true, it is going to be true again. Okay, if my first condition is false and my second condition is false, at that time, the output of combination of these two will become false. So it is entirely the inverse of what? AND operator. Okay, logical, you see the AND, right? So AND is giving you true when both are true. So this is giving me true in which case, if at least one is true, okay, it is going to be true. When it is false, when both the conditions are false, then only it is giving you the result as false. Understood, right? In the similar way, what we have the other operator as? We have one more operator, which is nothing but fifth operator. We have logical OR operator. Logical OR. The symbol we use is one pipe symbol. Okay. So the syntax for this is the same. I have condition 1 and I have condition 2. I want to combine these two. Okay. Use the logical operator just in between them. Okay. So for this also, the truth table is same. Truth table is same as truth table is same as what? Same as short circuit OR. Okay. So then what's the difference? Can you guess? So I have already explained to you about short circuit and short circuit OR, right? So can you guess? So how they are different? Both are having the same truth table. Then what is the difference between these two? When to use what? Any guesses, anyone? How the short circuit operator OR operator works and how the logical operator works. What is the difference between these two? In this case, let's say my first condition, I have 10 greater than 2. Okay, or let's say 10 is greater than, let me say 30. Okay, and I have short circuit OR operator, and I'm saying 10 is equal to 10. Okay, now if you see here, so here 10 greater than 30, what it is? False, right? And what is this? It will return me what? It will return me true. So in this case, it works in a similar way because first one is false, right? It goes to the other condition also, it will check that. Now let's say my first condition itself, 10 is greater than 2. Okay, and 10 is less than, let me say, 5. Okay, so this condition will result me what? 10 is greater than results me true. And this one results me what? True. So now short circuit OR operator, how it will work? When it is able to find out my first condition is giving me true, then it will not try to execute this. Okay, it no needs to go there because in truth table, if you see, either one is true, always the condition combination of the result is becoming what? True. Then why the necessity to check the other condition? Not required, right? So it is waste of time of executing that. If any condition, the first condition is giving you true means, then it no need to go for checking the other condition. So it will go and check the other condition when the first condition given you false. Okay, at that time only it will go and it will check. In remaining cases, what it will do? If the first condition is giving you true, it will simply stop the execution on the first condition itself, and it is going to give you the result. Okay, stop the execution of other condition, and it is going to give you the result. Understood? That is the basic difference between these two. You understood when to use this these things, right? So always remember the truth table here. If you can remember the truth table, you'll be able to identify how the condition works. Okay, and the last operator we have is what? XOR operator. The last operator we have what? XOR operator. Now, give me a minute. So, XOR operator. Or exclusive OR. It can also be called as exclusive OR. Okay. So, what is the symbol we use? This. Okay. This is the symbol we use for XOR operator. Okay. So, this operator will do what? this operator will also be able to combine multiple conditions and results what? Results false when all the given conditions are same. Okay, otherwise it will return me true. Okay, so what is the syntax for this? What is syntax? Write your first condition and symbol and write your second condition. Okay, to combine these two, use this particular symbol here. Okay, so what is the truth table for this? If you look at the truth table, you'll understand what is it, how it will work. Okay, so now I have condition 1 here, I have condition 2 here, and my condition 1 and condition 2 are combined. So let me say my first condition is giving me true, and my second condition is giving me false. Okay, so what will be the result? It is going to be true. So my first condition is false, and my second condition is true. It is giving me the result as true. My first condition is true, and my second condition is also true. In this case, it will give me false. My first condition is false, and my second condition is also false. Then also, it is going to return me true. You understood, right? When both are same, okay? When both conditions are giving you the same result, at that time, it is going to give you false, and both are different, okay? And if the conditions are giving you different results, at that time, it is going to give you the result as true. Understood, right? Till here, everything is clear? You have any questions on any of these operators? Because with this, we are done with the logical operators. So the way to remember them is, if you are able to remember the truth table, you'll understand how they work. So at the most, what is that we need to remember? Logical operators are used for the purpose of combining what? Combining multiple conditions. If we have multiple conditions and if you want to combine them, then we need to go for using logical operators. And the logical operators works based on the truth table, right? The first is this is the truth table. So what is we have? Logical NOT. We have short circuit end. I have explained the difference between both the ends, and we have seen short circuit R and the difference between both the R's, and we have XOR. So if you can remember these truth tables of everything, then it is going to be super easy for us to understand and to use them. So any doubts on this? Anyone is having any doubts? No, right? Any doubts, guys? You can mention me. You can just tell me yes or no. No, right? Or any questions? If we don't have any questions, I can move to the next topic. I hope this topic is clear for you. Am I audible, guys? Hello? Okay. Please respond, otherwise I will not understand. Okay. Now let's move on to the next topic. Okay. So the next operator that we need to discuss and the last operators to be discussed under operators topic. Okay. So the last one we have is bitwise operators. This is a bit tricky to understand, but don't worry. Okay. So we'll be most of the time we'll be not using these operators. Okay, but still it is always required to understand this. Okay, so there will be certain like if you're trying to participate in any certifications. Okay, at that time there will be questions that will be asked on these operators. And also there are certain applications, if you are part of those applications, networking applications and all, if you're trying to develop any networking applications, at that time you'll be using these operators. But remaining cases, we use these operators very rarely. Okay, but still it is important to understand this. It is a bit tricky to understand, but still let's try to put some efforts in understanding this. Okay, so I'll try to make it comfortable for you in understanding this, but let's see how it has to be done. So now when to use bitwise operators.
So we use these operators if we want to perform any operation on the bits. Okay, what are bits? So you know, right? Your computer understands what? Your computer understands only what? Mission language. What is mission language? Zeros and ones. Mission language is nothing but 0 and 1. Passing the current, not passing the current, right? 0 and 1. This is what basically your computer understands. Now we are writing a high level language. At to the last, what is happening? Your JVM is able to convert that to, it is able to take the help of the operating system, and it is able to convert, and it is able to convert into the mission language. Okay, mission level language, right? And that is what, that is how the code is getting executed underlying. Now, so what is that? At to the last, everything is going to be what? Represented in terms of bits. Now, if I want to perform any operation on top of bits, okay? If I want to perform any manipulations on the bits, then we have to go for using bitwise operators. What is it? To perform operation between the bits of the given numbers. Okay, given two numbers. Okay, if I have given you numbers and on top of the bits, so every number will be converted into a bit, and on top of the bits we will be able to perform the operation. So at that time we use bitwise operators. Okay, if you want to do any manipulations at a bit level, then we need to go for using bitwise operators. So what we have under bitwise operators? So we have totally 6 symbols under bitwise operators. Sorry, we have totally 7 operators actually. Okay, so there are totally 7 operators. So what are they? We have AND, we have OR. Okay, we have again this OR symbol, XOR symbol. We have right shift operator. We have left shift operator. We have right shift operator. So we have one more. This we call it as signed right shift operator, and we call it as unsigned right shift operator. Okay, we will see it anyhow. When I'm discussing it, I'll make you clear about that. And we have one more this. Okay, so these are the 7 operators that are there under bitwise operators. Okay, so how basically they work? Okay, so let's take each and every operator and let's try to understand. Let's try to convert them into bits. Let me write them into bits. Okay, and we'll try to do the manipulation. So when we use bit symbol, how the operations will happen on the bit level, we'll try to understand them now. Okay, so in which, just a minute, guys. Let me take the OR operator. Let me take AND operator first, or OR operator. Which will take? So let's take the AND operator. The first symbol we have is AND. Okay. So let me take this AND operator here. Okay. So now let's say I have an int of value a is equal to 10, and I have one more value int b is equal to, let me say, 3. Okay. I have these two values. Now, when I try to print them using this AND operator symbol, I'm saying A and B. So this will give me the result as 2. So this will give me the result as 2. So how it is giving me the result as 2? Let's try to understand it, for which we should be able to convert this into. So how we are trying to look at the symbols now? In the decimal format. So we will be able to understand our numbers if they are written in decimal. So that we are now 10 and 3, they are written in what? In decimal format. Now, to do the bit manipulation, they have to be converted into binary format. So how to convert a decimal
to binary and how to convert a binary into decimal. We will see that. Okay. For now, I have what? I have A and B. When you do an AND operator on these two using the bitwise operator, we will be able to do what? We'll be able to get the value 2. So how we are able to get? Let's try to understand. Before that, we need to see the what? We need to see the truth table for this. Let's see the truth table for this. Now you may be having a question here, like, so we have the same symbol and symbol, which came under the logical operators, right? So how to differentiate between these two operators is nothing but, see, bitwise operators always works on numerics. You cannot give any other type of value to it. You have to only pass numeric values to it. You understand what are numeric values, right? Integer values, integer, sort, byte. Okay, you have float, decimal, right? Char. All this comes under what? All this comes under numeric types. So you can only give numeric types to bitwise operators. You cannot give any other type. Now, if you observe the value, the types that we are giving for logical AND operator is what? Boolean values. So based on the type of the value that you pass, it will be able to understand whether it has to use this symbol as a bitwise operator or logical OR operator. You understood, right? So how your Java is going to differentiate between these two? So based on the type of values that you pass to that operator, it will decide whether it has to do a bitwise operation or it has to do a logical operation. Now saying that, let's look at this truth table now. So let's say my first bit. Okay, so it means my first value. Okay, I have given what 10. So let's say my first bit, if it is 0, okay, and my second bit, if it is 1, okay, the combination of these two. Okay, so what it will give me? 0 only. In the end, if my first bit is 0 and my second bit is 1, it is going to give me 0. My first bit is 1 and my second bit is 0. In this case, it will give me 0. If my first bit is 0 and my second bit is 0, it will give me 0. If my first bit is 1 and second bit is 1, in this case only, it will give me 1. So there we try to represent them using the true and false, right? Here we use the bit representation, zeros and ones. Got it? Now let's understand how the combination of A and B has given me the result as 2. Okay, so let's try to write it. So A is equal to what? A is 10. So how this is going to be written in like a binary format? How to write 10 in binary format? So all of you know LCMs? All of you know LCM, right? So we just put it here. To convert this into binary, we use 2 to divide this number. So how many times 10 gets divided by 2? 5 times, right? So what is the value that is remaining here? 0. Nothing is remaining here. It is able to divide it and the remainder is 0 here. Now again, can it be divisible? Yes, it can be still divided by 2. So how many times 2 will be able to divide 5? 2 times. 2 times gives me what? 4. So what is it? How much is pending here? 1 is pending. The remainder is 1 here. Just put it beside to it. Now 2 will be divided by 2 with what? With 1. Anything is remaining? Nothing. So 0 here. So totally what we have? 1, 0, 1, 0, 1, 0. So just put it left to right from top to top, bottom to top. So what is the bottom value we have? 1. Okay. So let's put this here. We have 1 and next we have 0 and we have 1 again and we have 0 here. Okay. So the binary representation for decimal value 10 is 1010. So now this is a binary, right? This is binary. This is a binary. I want this binary value to convert it into decimal again. So what we'll do from your left side onwards, sorry, from your right side onwards, start giving your values like this: 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. Okay. Now let's try to multiply these values and try to, after that, let's sum it. Okay. So how to do it? So 2 to the power of 0 is what? Anything to the power of 0, what will give you? Can anyone tell me? Anything to the power of 0, what is the result of it? Anyone?
1.
Right. It is 1. Now it gave me 1, right? 1 into 0. Multiply this 1 with 0. What is it? 0 only. Right? Anything multiplied with 0, it is going to be 0. Now 2 to the power of 1 is what? 2 only. Now 2 into 1 is what? 2. Now 2 to the power of 4, 2 to the power of 2 is what? It gives me value 4. So 4 into 0, 0. Okay, 2 to the power of 3, how much it will give me? It will give me 8. 8 into 1 is what? 8 only. Now, once you are able to evaluate them, try to sum this. So if you sum this, 8 plus 0, 8. 8 plus 2, 10. 10 plus 0, 10 only. Understood, right? How to convert a decimal value to binary and how a binary value can be converted to decimal. You understood the formula? You people are able to understand this, right? Is it clear now?
Yes, sir.
You understand this, then only you will understand how it will work. Okay. Now let's say, so hey, A is 10, right? A is 10. How to put it in binary bits actually? So in Java, what is the least byte value that will be taken? 1 byte, right? 1 byte means how many bits it will have? 0 bits. Okay. So that's the reason I'm just representing in 8 format here, in 8-bit format. So this is, we call it as 4-bit format. So we are using 8-bit format now, means one byte. So let me put all the values as zeros and let me put this 3 values here, 4 values here. So it is 8-bit representation. Still it is going to give you 10, but I'm trying to represent it in 8-bit. Instead of 4-bit, half byte, I'm trying to represent it in 1 byte. Okay, don't worry about it. Now, just put your values here. 2 to the power of 0, 1, 2, 3, 4, 5, 6, and 7. Right? So what is a binary representation of 10? This is how we write it. So 0, 0, 0, 0, 1, 0, 1, 0. This will give you what? 10. Now, similarly, let's try to evaluate the binary representation for 3. What we need to do? The binary representation for 3. Can anyone tell me what is the binary representation for 3? What is the binary representation for 3? Can you do the LCM for it and can you tell me? Binary representation. How to do it? Just put 3 here. 2 ones are 2. How much is remaining? 1. Right? So what I got? 1 and 1. Just put this 1, this one here, and next this one here. Okay, sorry, from down to up you have to write, right? So this is how we have to write 1 and 1. Okay, and remaining all you can keep it as zeros because those 2 values only it is sufficient for saying whether it is 2 or not. Okay, now same if you wanted to again convert it to what? If you want to convert it to decimal format, you can use that for signature, like how to use the 2's complement and convert that into decimal again. Okay, to convert a binary value to decimal, we use 2's complement. So this we call it as 2's complement. Okay, we call this approach as what? 2's complement. So 2's complement will be used when if you want a binary value to be converted into decimal. Understood? Now, what is the value of binary value of 3? This one. Now, let's try to apply that formula combination here. What is the combination? A and B. Now, all of you know the truth table, right? So now 0 and 1. What is the result you will get? When your first bit is 0 and your second bit is 1, what is the value you will get? Based on the truth table we have discussed. Please respond. Someone. When your
0.
first, yeah, it is going to be 0. So when both are ones,
1.
right. If both are zeros,
0.
so if first bit is 1 and second bit is 0, then
0.
right. Yeah. So you can just try to remember this truth from this one is there, right? Try to remember this. Okay. So look at this and try to remember this. Then you'll be able to tell me that. Okay. So if first one bit is 0 and other one is 1, 0 only. First bit is 1 and other one is 0, 0 only. If both are zeros, zeros. When it is going to be 1, if both are 1, then it is going to be 1. So that is what, right? So remaining all are zeros. Now this is the binary representation of 3 actually. So can we convert this to decimal to understand whether it is 3 or not? Sorry, it should be 2 actually. So the result is true, right? The result is 2. Now let's see whether it is going to give me 2 by using the 2's complement. Let me convert this using the 2's complement into decimal value. Okay, so how to put it? So you have already 2's complement written at the top, right? Now look at this and tell me for this entire result, let's try to convert this into decimal. So 2 to the power of 0, 1. 1 into 0 is 0 only. Okay, next I want 2 to the power of 1. 2 to the power of 1, how much it is? 2. 2 into what? 1. 2 into 1 is what? 2. So remaining all are zeros, right? No need to multiply because anyhow it is going to give me 0 only. And after that, what you have to do? Once you are able to evaluate, what you have to do? You need to sum this. So what it is going to give you? 2. Are we right now? So if you are using n symbol, if value of a is 10 and b value is 3, and if you use AND operator, so what is the manipulated value that you are going to get as a result? 2. So shall we check and let's see whether we are right or not? So let's write a program for this and let's check this. So let me use the same program here, logical AND. Okay, I'm just writing a comment here saying that bitwise operation. Okay, so what is that I have used? I'm trying. So we have 10 and 3. So let me say a is equal to 10 here. Okay, b is equal. I'm assigning a different values 3 here. Okay, so this is the combination which I have taken, right? Now what I will do? I will say system dot out dot println of what? A and B. Okay, so this will give us the result as what? This will give me the result as what? 2. Okay, let's see whether it is giving me the result as 2 or not. Okay, let me save this. Let me save this program. Just a second. Why it is giving me this? I've already saved this, right? Okay, there's the problem. Okay, now let's come here to our compiler, sorry, command prompt. And let me compile this program again. Java C, logical operators example dot Java. And let me click on enter. So yes, it is able to compile successfully. Let me use Java command for executing this. So you're able to get the result as 2, right? Yes, it is able to print you 2. So everyone is able to understand how the the bitwise AND operator is working. Is it clear, guys? Say yes or no.
Yes, sir.
Okay, thank you. So let's move on and let's see the other operator we have. The next operator we have is, let me see. Oh, I'm sorry, actually. I didn't notice the time. Okay, it is already 8:10, right?